This is the video for conveyors routines. I'm going to go over two routines, one here on the left and one on the right. We'll start with the one on the left. It's the one that initializes the game. It's going to fill 20 values at down cases with 0. That has to do with the vertical conveyor on the left. Then it's going to fill numerically 240 showcase values with 0. That has to do with the conveyors on the right, the 5 horizontal conveyors. Then it does a reset to the probability distributions because this is initializing the start of the game, so it wants to start all the probabilities at the beginning again. So the game is exactly like it was before. Then it says set equally likely to 16. It's going to use that down here for its equally likely probability distributions. Then it sets S to the game number. It's going to use that for the seed for the probability distributions. Then it fills the 10,000 values at drop times with 0. That's the times that it's going to tell it when to drop a case from what conveyor, from what chute onto which conveyor. Then it says set J to 3, and then for I of 0 to 15, one at a time. So it's going to go around here 16 times. Each time it's going to set over value sub I, and that's going to go from 0 to 15, to the value of J, which is going to go to 3 to 48. The over value is the time it's going to take a case to travel from the chute that it was dropped from over to the vertical conveyor on the left. That is to say, if it gets dropped from the first chute next to that conveyor, it's only going to take three clock times to get there. But if it's dropped from a chute on the far right, the number 16 chute, that case is going to take 48 clock cycles to get over to the left. So this is just a table of values that it will tell it how many clock cycles it's going to take depending on what chute is dropping the case onto the conveyor. Then it says for I of 0, and down here next I 79 times, it's going to go around here 80 times. It's going to get a random number of cases in each one of the 80 chutes. There's 16 chutes on a horizontal conveyor, and there's 5 conveyors. 5 times 16 is 80. So it gets a random value of equally likely, and we know it's going to be from 0 to 15 because it says there's 16 possibilities. Then it's going to take it and divide it by 4. Well, it went from 0 to 15. Now it's going to go 0 to 3. Then it says put at chute count sub I, and there's 80 of them. It's going to go around here 80 times. It's going to set it to the value 4 plus that K. So now we're talking about it going from 4 to 7. So each one of the chutes is going to have from 4 to 7 cases in the chute when the game starts, but they're going to be assigned random values. Next it says for L of 50, and way down here it says L to 1920 at a time. This is going to be the times. That is, this is going to be clock time 50 it's going to start at. And the reason it wants to start at clock time 50 is because if a case gets dropped from a chute on the far right, it's going to take it 48 clock cycles to get all the way over to the left. So this is making sure there's enough time there that it could do that. All right, the next thing says set U to 0, and then for I of 0, and down here to I goes to 4, one at a time. Well, that's for each one of the horizontal conveyors. It's going to go around for each one of them for this particular time L, which started at 50. Then it says get a random number again using the peck action, using the seed 1 plus the game number, equally likely, meaning that's 16, so it's going to be a value from 0 to 15. That's going to tell it which one of the shoots the case is going to drop from. The 0th one to the 15th one. There's 16 of them. Well, first it sets its time to L, and we have that starting at 50. And then we add to it the value of U. U changes down here by 2,000 for every one of the horizontal conveyors. Remember, there's going to be 1,200 values already to be assigned to each one of those conveyors for the 1,200 cycles that's going to happen. It keeps them 2,000 apart, and the offset, that's plenty of space. Okay. Then it says, all right, I added my U to my T, that's that offset. Then I subtract from it the over value. In other words, I have to drop this onto the conveyor ahead of time, 48 clock cycles, if I drop it from the 16th chute, all right, the one on the far right. If I drop it on the one next to the vertical conveyor, it only takes 3 clock cycles to get onto the conveyor. So I have to go back in time for the one on the far right to make sure that it gets to the vertical conveyor at the right time. Then it sets V to the drop time sub T. Well, we zeroed them all out up here at the top, but now we're going to possibly put a value in there. So we're going to, first we multiply the value that's there by 100, then we add to it 1 plus our value of K. Remember, K up here tells us which one of the chutes is to drop the case onto the conveyor. So here we're going to tell it, well, which chute was it? But there may eventually be more than one chute that is going to drop a case on that conveyor at the same time. It's not very likely, but it may be the 16th one drops at the same time the 4th one drops. So at this time of T, there could have been another one there already. So that's why we multiply it by 100, add in our new one, and then put that value in drop times. Well, next it says add 2,000 to U. That's so it goes to the next times for the next horizontal conveyor until it does all of them. And we know it's in this loop doing all the times 20 apart. All right. This initializes the game, and the truth be known that it already knows when it's going to drop cases onto the conveyors. Now over here, we're going to see how it displays them by putting a 1 at showcase plus U down here. All right, we're going to start at the top. First, it sets J equal to IG. That value of IG changes every time the cycle changes. That's going to go from 0 to 1200, say. That's our clock. So right now we have our index in J, that's our offset, to the position of the time we're at. Then it sets K to 0, and it says for I of 1, and way down here we have next I to 5, one at a time. It's going to go around for each one of the horizontal conveyors. Then it says set V to drop time sub J. Well, that's going to be the time for this particular conveyor. At this time, are you going to drop something? Well, if here, next thing it says, if that's equal to 0, we're not dropping anything now. So we go right down here to DE, and we go to the next conveyor by adding 2,000 to its offset, and 16 to the offset that is used for its chute count. Here U, we'll see that soon. Alright, so it sets u then to this value of v if it wasn't 0, mods it with 100. Remember down here we multiplied it by 100, so we could put multiple ones in the same number. Now we have to pull them apart. So we mod it to get one of them to see which particular chute is supposed to drop a case. Then we subtract 1 from it. Well, that's because down here we added 1 to which chute it was. Here we're going to subtract that 1 back away again. Then we add that to the value of u. U has to do with which one of the conveyors we're at right now. So we add k to u. And then we say, add 1 to the missing cases. The missing cases has to do with, did a chute run out of cases? And if it did, that's a bad thing, and you get told that, hey, you ran out of cases in one of your chutes. Then it says, branch if less than the chute count of u is less than 1, indicating, well, it doesn't have any cases, so then it goes to DD down here, goes around again to see if there's another one that needs to be dropped on this conveyor. However, if it says, oh yes, there is at least one case on this conveyor, so it says, well, then add 1, subtract it back from missing cases it really wasn't missing, and also subtract 1 from that chute sub u. Because now it is going to display that there's one less case. It just dropped a case, there's one less case. Then it has to figure out the beginning position for that in show case. It's going to multiply that value of u by 3, and then it's going to add 2 to it. It's multiplying it by 3 because you remember there's 3 clock cycles it has to move as it's going from one chute on the conveyor to the next chute, to the next, until it gets all the way over to the left and can go down the vertical conveyor. So the show cases actually has 3 times as many positions as does the chute count. Well, once it says where it's going to show that case on the conveyor, then it divides that v value by 100 and goes back to the top here to see if there possibly could be a second chute that's supposed to drop a case at this very same time. Not very likely, but it does happen. Well, if there aren't any more cases to be dropped off of chutes, it goes down here to DE. Then it adds the 2000 offset to go to the next conveyor's data. 2000, it could have only have gone 1200 because that's how many cycles there are between the different conveyors. And then it adds 16 to the offset for the chute count, and then that's the end. Goes around all 5 times. This happens every cycle time. IG gets increased by 1, and it does this again. Alright, this is the end of the video for conveyors routines.